Hello students, in this video I'll be going over the second half of lesson 15.3, which you can see I started right as 15.1, which starts on page 271. If you remember from most of the school year, every now and then we'd be going through a math lesson, and as soon as everyone was seeming to get the lesson, I would say, well, don't worry, it gets harder. This is where I would normally say that. This is where the chapter itself starts to get a little bit more difficult. It's probably been somewhat easy, or just felt like counting cubes, but I really need to make sure that you're paying attention in this one because there are some trickier things that really build on concepts that we have learned before. So I'm actually going to start by doing a few little reminder things about both actually the homework you did yesterday as well as things from earlier in the year, and then we'll get into the actual lesson. So the first thing that we're going to do is we're going to look at this rectangular prism and find the surface area of it. Remember that if you've learned the pattern with rectangular prisms, that there are three pairs of faces that are the same shape. So I've got one here in the front that is 4 by 6. There's also going to be one in the back. So 4 inches times 6 inches times 2 will give me the length or the surface area of this one face and the one in the back. This one on the top will be 3 inches by 6 inches. So 6 inches times 3 inches, and there will be a similar one right at the bottom, times 2. And then this face right here is 4 inches tall and 3 inches wide. So the last thing to multiply will be 4 inches by 3 inches, times 2. 4 times 6 is 24 inches squared, times 2. 6 times 3 is 18 inches squared, times 2. And 4 times 3 times 2 would be 12 inches squared, times 2. 48 inches squared, 36 inches squared, and 24 inches squared. If I add all these up, these two will be 50 together. All of that would be 98 inches squared. This is not a problem that was in your book. I probably should have said that before we got started. But just one to look at and remember how we find the surface area of something. Look for faces that are the same size, and then you can just multiply them by 2. Now, next thing that we need a little bit of a reminder on is how to find the area of just a normal two-dimensional triangle. We're not even going to worry about it on a three-dimensional shape yet. Remember that for these, I just need to do 4 times 6, the length or the height times the width, and that will tell me how many things are in here. Remember why that works. If I just drew a rectangle up here real quick that was 3 cubes tall and 5 wide, what that's saying is I have 3 rows of 5. So 3 times 5 is going to be all 15 of these squares. With a triangle, though, we have 2 sides of a rectangle, right? But instead of the other 2 sides, it's cut down the middle with this line. That would be like cutting this rectangle like that. I would say that's exactly half. So the area of this triangle would be half of 15. In the same way, this would be a rectangle that was 3 by 4, but it's been cut in half. So I'm going to write the equation up here. Remember that for triangles, the area is equal to 1/2 of the base, one side, times the height. And remember, to find the height, should I use this 5 inches or should I use the 4 inches? The height is the tallest point of the triangle from whichever side I choose as the base. So let's say I choose 3 as the base. The height is going to be a right angle. It's going to be perpendicular, a straight line to the highest point, which is this right here. Because if I did 5, remember this rectangle. I'm just doing one side times the side that makes a right angle with it. I'm not multiplying this slanted angle. I'm doing 3 by 4. Same thing here. 3 by this other side of the rectangle, or 3 times 4, because that's the highest point. So the equation would be 3 times 4 times 1/2, or divided by 2. So 1/2 of 4 is 2. the area of this would be 6 inches squared. Let's look at this one real quick too as a reminder. A little bit of a trickier triangle, because in this one we had a nice right angle. This one we've got a nice right angle. This one we don't have a right angle as obviously. So this is the easiest one to choose as the base, but neither of these are the heights. Do you see how they're not perpendicular? They're not making a right angle with the base. But I've drawn this dotted line here so we can make a right angle and see, from the base, this dotted line is my most direct path to the highest point of that triangle. So the area of this triangle is not 8 times 6, but 8 times 5 times 1/2. Half of 8 would be 4, so 4 times 5 equals 20 inches squared. And again, think about if this line here, if I just shifted that over so that it was right here instead, along that, 8 times 5, this rectangle, if this entire thing was a rectangle, would be 5 times 8, or 40 inches. But it's just half of that, 20 inches squared. And just to make sure we're really feeling comfortable with triangles, let's do this one quickly. 5 inches, 5 inches, 7 inches. This one is not a right angle, so that's not the one I have to worry about to find the area of this triangle. This will be important for some of the 3D shapes we're going to get into, but I don't need this information to find the area of this triangle. 5 times 5 times 1/2. So the numbers I chose for this won't work out as nicely because I'm taking half of an odd number. But that would be 25 divided by 2, which is 12.5 inches squared. Hopefully that helps you remember how to find the area of a triangle. We did look at that earlier in the year. That's going to be very important for the rest of this lesson, because now we're going to take those triangles and put them on a 3D shape. So this, we would actually still say is a prism, because it is 2 different bases that are parallelograms that are congruent and are joined by rectangles. So this is a triangular pyramid as opposed to the rectangular pyramid that we started this lesson with. I drew the net as well, and you can also find that in the book. Remember that with the rectangular prism, we've got lots of pairs of similar shapes. But how many similar shapes do we actually have here? Let's look at this shape here first. This is 9 centimeters by 3 centimeters. And that would be this back wall here. The base is 9 by 4, so that's a different size. I can't just multiply either of those by 2. And actually this slanted face is 9 by 5. So all 3 of these are different sizes. I need to measure each of those. However, remember that with a prism, you've got 2 congruent bases, which means they're the same size. This triangle back here is 4 centimeters, 3 centimeters, and 5 centimeters. So is this one. So the triangle I can multiply by 2. But these other 3 faces are all different. I need to find them all out individually. So let's just look at this one first. This is 5 centimeters by 9 centimeters. So 5 centimeters times 9 centimeters. If you remember from before, I'd multiply it by 2, but that's because there were 2 of each of these. Not the case here. That's all I'll need to do for that face. This one is 4 centimeters wide by 9 centimeters. So 4 centimeters times 9 centimeters. And then finally, this one is 9 centimeters by 3 centimeters. So again, you can see all of these are different. I need to do them each individually. All that's left are these triangles. And looking up here, I need to find a base and a height that is perpendicular to that base. So the 5 centimeters that is this slanted side isn't actually very helpful. I want to know the base, which is 4, and the height, which is 3. And don't forget, I need to multiply it by 1/2, because otherwise I'd be saying that it was a full rectangle, which is not true. So 3 centimeters times 4 centimeters times 1/2 to make it a triangle. And all of that times 2, because there's 2 triangles. Okay, so now you just go through, find out the different surface areas of these different faces, and then add them together. So 5 times 9, that's 45 centimeters. squared. 4 times 9, that's 36 centimeters squared. 3 times 9, which is 27 centimeters squared. And then 3 times 4 times 1/2 times 2. So actually what I'm going to do to try to simplify this, if I'm taking half of something and then doubling it, those basically cancel each other out, don't they? So I'm not going to have to do either of those. I can just do 3 times 4, which ends up equaling 12 centimeters squared. And actually, if you think about it, that makes sense. If I pick this triangle up and fit it up here, that would make a full rectangle that was 3 by 4. So I've got all of my different sizes. I just need to add them up now. 45 centimeters squared plus 36 centimeters squared plus 27 centimeters squared plus 12 centimeters squared is equal to 120 centimeters squared. So as you can see, that is more complicated, but we can still get there to an answer. We just need to find more of the faces and to make sure we know which ones are actually similar. Let's look at one more to make sure that we're feeling comfortable before you get started on your homework. This is a slightly differently shaped triangular prism, but you can see, even though it's been rested upon its side, I've got 2 bases that are congruent, and they're parallelograms, and they're connected by rectangles. So they're different size, but this is technically the same classification of a shape. And then here's the net. Let's just go ahead and dive into it by looking at faces that have the same shape. Let's start by looking at this one. Are there any that are also 13 centimeters by 8 centimeters? Well, actually, in this case, there is this one here. Because if I was looking at this shape, I can see this is 13 centimeters, and so is this. So that one I can actually multiply by 2. That makes my job a little bit easier. 13 centimeters times 8 centimeters would give me one of those, and I need to multiply that times 2. Now let's look at this rectangle. This one is 10 centimeters by 8 centimeters, and I can see there's not even another rectangle there. So that one's a little bit quicker. 10 centimeters times 8 centimeters. And then let's look at these triangles. Both of them have a 10 centimeter base. And then this slanted side is 13 centimeters, which it tells us here. But remember, this is not the height. The height has to be perpendicular to the base. So actually this 12 centimeters is the other height that I want to know. And because these are the same size, yes, I can just find out one and then multiply them times each other. So that would be 10 centimeters times 12 centimeters. Remember, it's a triangle, so I have to multiply it by half. And there's 2 of them, so times 2. And now I can go through and just add up these numbers once I've done the multiplication. 13 times 8 would be 104 centimeters squared. I need to multiply that by 2 though. 10 times 8, that is simply 80 centimeters squared, and that one does not need to be doubled. This one I'm multiplying by half and then doubling, just like the one before. So I don't actually have to do either of those steps. They cancel out. And 10 times 12, that is simply 120 centimeters squared. So I still need to do 104 centimeters squared times 2. That is 208 centimeters squared. Add all of these up. 208 centimeters squared plus 80 centimeters squared plus 120 centimeters squared equals 408 centimeters squared. All right, and that's it. So you can see it's pretty similar to rectangular prisms, and that you're just finding the different faces, their unique area, and adding them together, but the triangles add an extra level to make sure you understand. Your homework is just page 175 to 176. Remember that your quiz corrections also need to be done by the end of today and sent to me. Let me know if you have any questions, and I'll see you during our Zoom. Thank you.